Hello guys, I'm back. Become a master in process simulation is not an easy task, but if you are a chemical engineer and want to work with plan design, operations, or research and development, I strongly recommend you to add that to your curriculum, because companies use process simulation software to improve the productivity of the chemical process engineer during the development of the heat and material balance. Based on that, today I will share with you 10 good habits that you must have for process simulation. My name is Jeferson Costa. I'm a chemical process engineer with expertise in plan design. On internet, I teach students, chemical process engineers, how to use process simulation softwares applied to plan design. 10 Good Habits for Process Simulation is available on the book Chemical Engineering Process Simulation. In this video, I extract the main idea of each good habit, and I will share with you my comments based on my experience in chemical process engineering and plan design. As the first habit, we have build your process simulation to meet an objective. The purpose of running a simulation should be clearly defined upfront. Every time that you open or you start a new process simulation, you must have a clear objective at your mind. Sometimes we get the results we want, sometimes we don't, but without knowing what you are looking for, it's not effective to start a process simulation. For instance, if I want to install a pump in the field and I will use the process simulator to help me with the design of the pump, I need to know the fluid, the discharge pressure, the inlet conditions of the pump, because without that I will not be able to perform or to convert my process simulation. That is not only for plan design, but also if you are working with operations and you want to optimize your process. You need to know what kind of variables you need to do variations or to do some kind of settings to verify if the performance, a better performance, is achieved or not. The process simulator is a tool, but any tool is ineffective if you don't know for what you will use that. So keep that in mind before you start your process simulation. The second habit is identify the system or process and draw an envelope. In some cases, not the entire flowsheet will be simulated. Once you have the objective into your mind, it's time to define the better limits for your process simulation. Sometimes you just need to simulate only equipment or only one unit of your process. For instance, I deal with the biomethane production, and the biomethane production has the biogas generation, has the pretreatment, CO2 removal, post-treatment, and gas delivery. And depending on the objective of my job, of my deliverables, I will get only a specific part of my process simulation. Most often, when you deal with suppliers, for instance, they will send to you only the licensor part of them. For a hydrogen plant, for instance, they will give it to you the process flow diagram and the heat material balance related to the steam methane reformer, while you need to deal with the utilities. So eventually you will not perform the process simulation for the hydrogen production, but you will need to perform the process simulation for the utilities. And all of these are based on the objectives that you have when you start your process simulation. As habit 3, imagine what is going on physically. The engineer should imagine the state and flow pattern for a feed or product stream. When you are dealing with process simulation, we are trying to replicate what happens in real life. Based on that, every time that you do some kind of modification, you must imagine what happens in the field. For instance, you are dealing with a saturated stream, and based on the environment conditions, eventually you will have the condensate formation in your pipeline. So because of that, you will need to add a vessel separator. Or if you are doing a pipe sizing and you increase too much the velocity, you must imagine, or you must think about the vibration that can happen in the field, for instance. And all of this imagination, all of this experience will help you to verify the results and have the better choices for your process simulation. Habit 4 is translate the physical model to a mathematical model. Pick the right process simulation software to perform the right application. One common question that I receive is, what is the best process simulation software? And my first answer to that is the one that is available to you. However, you must understand that different process simulation software can perform different tasks or was designed for different tasks. For instance, the Aspen Hysys is well designed or fit best for hydrocarbon processing, while Aspen Plus fits better for chemical process. And if you need to perform a process simulation for a batch, you should not use the Aspen Hysys because it was not designed for that. The Aspen Plus fits better for that, and you will see that there are specific components or blocks for batch process simulation. So when you are performing your process simulation, you need to understand that, because if you are dealing with hydrocarbon processing, or eventually you will not use the same software that you need to evaluate wastewater treatment or pharmaceutical industry. And that is very important, because if you use a wrong tool to get the results, you can base all your decisions in wrong information. As habit 5, know your components. Understanding the components will enable the engineer to choose the right property estimation method. One of the first things that you do when you start a new process simulation is to add components to your process simulation. And based on the components that you add to your process simulation, you will choose the property estimation methods or the fluid package if you are talking about Aspen Hysys, for instance. And knowing your components is very important, because the fluid package is what adds all the thermodynamics results to your process simulation. So if I'm doing a steam generation process simulation and I use Peng-Robson for my process simulation, I will find some results, but that will not be as much accurate as if I use the ASME steam for the semi-process simulation. And moreover, sometimes we have fluid package or property estimation methods that do not fit one with another. When I'm dealing with gas sweetening, for instance, sometimes I need to use for my gas stream a fluid package that is not compatible with other components that are available in my process simulation. So knowing your components will help you to choose the best fluid package for your process simulation. Habit 6, know the context of your feed stream. It's important to know the origin, composition, sampling conditions, and the presence of impurities. When you are adding the components for your process simulation, you must understand how is the conditions where it was taken. For instance, when I'm dealing with the hydrocarbon for purification of hydrocarbons, for instance, or dehydration of hydrocarbon, I get the chromatography results, and the chromatography results is a analysis based on dry conditions. And depending on the conditions of my feed gas, it can be saturated. So I need to understand that before adding the components for my process simulation. Eventually, I will need to know the pressure and the temperature to make sure that the quantity of water that I can have in my stream is correct. Because if I consider a quantity of water or moisture in my feed stream too low for my process, when I design my system and I start running that, I will not achieve the performance because my equipment or my process was undersized. Habit 7. Know your components' boiling points. It's a good practice to have the chemicals arranged in the ascending order of their boiling points. This habit is very important when you are dealing with distillation or condensation of fluids, because if you know the boiling point of each component available in your process simulation, you can predict which one will condensate first or later, and that will help you to evaluate the results. Some days ago, I was in a workshop and there was a discussion related to how to remove nitrogen from a biogas stream to produce biomethane. And based on the boiling points of each component, the main components are CO2, methane, and nitrogen. In this case, I verified that it's not possible to remove nitrogen from the biomethane even though I use cryogenic temperature if I want to have as product methane, because the methane will liquefy or will condensate first than nitrogen, and based on that I will not produce a gas rich or without the nitrogen. I would need to produce the LNG, and if my application is for gas application, for instance, I will need to vaporize the LNG again to have my product, and that leads to a lot of energy to be used. So knowing the boiling points of your products is very helpful every time that you deal with vaporization, condensation of fluids. Habit 8. Keep track of units of measure in all calculations. Errors on units of measurement are very serious and the easiest ones to avoid. I insist in my videos that you must be clear to you what are the system of units that you must use in your process simulation, and in my point of view, as much as possible, you should use the ones that are defined on contract. And you need to understand what is bar G, what is bar A, the temperature conditions for volume flow of gases and pressure conditions for volume flow of gases, because all of that will influence the results of your process simulation. Habit 9. Always do a simple material and energy balance first. Performing a quick material and energy balance enables the engineer to have an order of magnitude. This will depend how complex is your process or will be your design. Here, for instance, when I got with some opportunities, I need to measure how much biomethane can be produced from a source of biogas. So I do simplified calculations to achieve the amount of biomethane that is possible to produce. And when you are doing your process simulation, if you already know the order of magnitude of the results that you will achieve, that is good, because if some results is very different from what you are expecting, that you can identify that and verify, do a double check in the inputs to make sure that everything is okay. Habit 10. Plot the phase envelope for important streams. It is extremely important to know in which stage the stream is, like subcooled or saturated, for instance. Every time that you are performing your process simulation, you want to know what is the behavior of your fluid, because that will help you to understand why the temperature is not increasing or why the temperature is not decreasing. And when you add the phase envelope for your process simulation, when you verify that, you are able to identify the pressure and temperature conditions for having gas, for having liquid, for having a mix of gas and liquid, if we are talking about a mix of gases, for instance. And also you will be able to identify the critical point where you are not able to have a mix of gas and liquid. All of that helps you to understand the behavior of your fluid, and with all the others habits will guarantee that you will perform your process simulation with a good efficiency. With this, we pass through the 10 good habits for process simulation. And just to summarize, build your process simulation to meet an objective, identify the system or process and draw an envelope, imagine what is going on physically, translate the physical model to a mathematical model, know your components, know the context of your feed stream, know your components' boiling points, keep track of units of measure in all calculations, always do a simple material and energy balance first, and plot the phase envelope for important streams. If you want to know more about chemical process engineering and plant design and become a master in process simulation, I recommend you to take a look in my website, jeffersoncosta.com, and subscribe to my YouTube channel and also my Telegram channel. So guys, this is it. And before I go, let me know in the comments what is the most important habit in your point of view. My name is Jeferson Costa, I'm a chemical process engineer with expertise in plant design, and I'll see you soon in the next video. Bye!